Okay, we'll definitely need to give people mics because otherwise, there's no way. We don't have a name for the $25,000 car yet.
It's a great question, though.
Yes, we will be manufacturing cells in Berlin. Yep.
Thermal management system?
Oh, you mean like the home HVAC? Yeah, I mean, that's a pet project that I'd love to get going on. I don't know, maybe we'll start working on that next year. Because I just think man, you could really make a way better home HVAC system that's really quiet and super efficient and, yeah, super energy efficient and also has like a way better filter, for particles and, yeah, and it works very reliably. And we've already developed that for the car. Like, so the heat pump in the Model Y is really pretty spectacular. I mean, it's tiny, it's efficient, it has to last for 15 years. It's got to work in all kinds of conditions, from the coldest winter to the hottest summer. So we've actually already done a massive amount of the work necessary for a really kick-ass home HVAC. And they could also like stack them. So if you want to, depending upon the size of your house or whatever, how much you need, you can just basically stack them. Just have a very compelling, super efficient home HVAC, and then you can also communicate with the car, and it'll know when you're coming home. So it's like, oh, I don't need to keep the house cold all day. I just cool it down because I knew you were coming home. So the pack can communicate with the car and just like really dial it into when you actually need cooling and heating. It'd be great.
Fun product.
Yeah.
Just quick question. So I'm a huge fan of car camping in my Tesla with my dream case, like my all-time favorite activity. Is it going to be possible to get climate control to the back of the Cybertruck? Because that would be the ultimate camping machine if we can get all-night climate control.
We'll try to do that. Yeah, I agree. That'd be really cool. Yeah.
How does the ICE industry look like for in the future?
Well, I don't think there will be an ICE industry long term. I mean, well, I guess there might be like a few things that are like, it's a like curious thing. Like, I mean, there's still like some steam engines made somewhere, but like they're just basically sort of quirky collector's items. I mean, that will be the future of the internal combustion engine car.
Curious about Cybertruck. It was interesting to see where you had it in on the battery technology front. I'm sort of curious what you see for it in the production front. Is its volume, trucks are so popular in America, do you see its volume equaling the 3 or the Y in the future? And also, were you able to get Tesla's able to legally be sold in Texas as part of the Giga Texas deal?
Well, it's hard to say what the volume exactly would be for the Cybertruck. The orders are gigantic, and we have like, I don't know, well over 500,000 orders. I think maybe 600,000. That's a lot, basically. We stopped counting. I think there's probably room for, I don't know, at least like a unit volume of like 250 to 300,000 a year, maybe more. Now, we are designing the Cybertruck to meet the American spec, because if you try to design a car to meet the global, the superset of all global requirements, it basically, you can't make the Cybertruck. It's impossible. It really is designed for the American market, but this is the biggest market. Our North American market is the biggest market for pickup trucks by far, or large pickup trucks. And then I think we'll probably make an international version of the Cybertruck that'll be kind of smaller, kind of like a tight Wolverine package. It'll still be cooler, but it'll be smaller, because you just can't make a giant truck like that for most markets. So yeah, but it's gonna be great. And I don't know. I think probably we'll be able to sell directly in Texas. We do pretty well right now, but it is a bit weird not being able to actually conclude a transaction in Texas. But it's got to be like a click on a server based in California. But weirdly, we can do leasing in Texas, but not selling. But hopefully that'll get cleared up in the future.
What I'm most curious about, these innovations are incredible, but on my drive up here, fully on autopilot for 400 miles, the entire state is brown. And this is ultimately about climate. Has there been some analysis done if all these things are achieved? What will its direct impact be on climate?
Well, I mean, I think it will have a very significant impact, because it will stop the CO2 ppm from growing as it is every year. I mean, I should say, like, I try to view the whole climate thing as a science question as much as possible. Science, you always question your hypothesis. Is it true? Is it not true? Or assign a probability to a given hypothesis. And I should say that my original interest in electric vehicles predates the climate issue. Like, just when I was in high school, I thought, man, if we don't figure out electric cars, the whole economy is going to collapse when we run out of oil. We better figure out electric cars and sustainable energy, or civilization is going to crumble. it was only kind of later that the significance of the climate risk became apparent. We were also able, using fracking and other types of technology, to access a lot more fossil fuels than previously thought, which is, helpful for lowering the cost of gasoline, but it's pretty bad for the total tonnage of CO2 that you could put in the atmosphere. It's now greatly beyond what people previously thought. But this is, as we were just going through in this presentation, it's like it is a absolutely monumental task to accelerate the advent of sustainable energy. I mean, the entire global economy is still more than 99% dependent on, or roughly 99% dependent on fossil fuels. So although electric cars kind of get a lot of press right now, they're still very few. As a percentage of the total global fleet, is practically nothing. I would say, yes, less than 1% of the global fleet is electric right now, because of 2 billion cars and trucks and whatnot in use. So there's a massive amount of work ahead, just insane, like hard to comprehend how much work is ahead to get the new vehicle production to be sustainable, to massively increase the amount of stationary storage, which is critical because renewable energy is intermittent. Wind and solar is intermittent. Sometimes the wind doesn't blow, and this obviously sun doesn't shine at night. So you got to have batteries. A massive number of batteries.
It's hard to measure in direct impact, but it's an experiment that we shouldn't be performing. And the sooner we can sort of end the experiment, the sooner we can kind of move on in a fully sustainable way that is actually lower cost. I mean, I think the thing that people haven't fully internalized is once we do get to the 25K car, the ownership cost of that car is incredibly lower than the prior car. And then on the solar side and wind, with the cost of solar and wind coming down and with batteries coming down with them, the actual cost of energy on the grid is going down. So we're sort of moving towards a sustainable, lower cost future. So there's not really a sacrifice.
That's true. It is a false dichotomy to say that it's either prosperity or sustainability. This is often used, by oil and gas to say like, oh, well, do you want people to lose their jobs? Do you want lower people's standards of living? Do you want to, make all these economic sacrifices? Really, in order to have sustainability? And the reality, as Drew was saying, is that a sustainable energy is going to be lower cost, not higher cost, than fossil fuels.
First, thanks for having everyone. And as telling a friend, the one company to go work for that's going to have the biggest structural impact over the next 10 years at scale, it's probably Tesla. So kudos to everyone at Tesla for what they've done to this point and going forward. The two questions for you, as you've looked at the auto and the storage markets, I know you've talked about it at kind of 50-50 long term, but it seems like a lot of the battery cost curve achievements that you've presented today really make some of these storage opportunities much more feasible over the next 5 years. And so I guess the first part of the question is, does your calculus upon learning and improving these things change on that 50-50 mix, or is there a role where storage becomes bigger? And then the second part of the question, with all these huge grand visions, who's going to be with Tesla from a corporate perspective accomplishing these things? Obviously, Tesla can't do it alone, but when you look at some of the traditional auto industry or power, et cetera, I don't see a lot of other Teslas.
So there's a lot of companies in China that I think are doing great work with electric vehicles and also with stationary storage. Although we don't see that much in the US yet, but I think probably we will in the future. I don't know. I mean, obviously, we're doing everything we can to encourage other companies to move to sustainable transport and also, make stationary storage batteries. We opened up, made our patents freely available. We really try to tell these companies, hey, you really need to do this or you won't exist in the future. But they don't believe it, So, I mean, we've talked until we're blue in the face. What are we supposed to do? But we really are hopeful that other companies will also do what we're doing, and that will make a sustainable future come sooner.
From a fundamental market size perspective, like we did the first ground up work to show the size of the market in terawatt hours, and they are roughly 50-50. 10 terawatt hours for transportation, 10 terawatt hours for the grid. And part of that is because the grid batteries, because when you're making a power plant, you're making a large investment, are 25-year assets or greater. If the grid batteries were 10-year kind of things, the grid market would be bigger. But because it's a longer duration asset, they're roughly the same size.
Thinking long term, is there any other segments that this new battery will be able to disrupt or electrify beyond just the initial Model 2 or cheaper sedan, like a boat, boring company, Luke, plane, boat?
Where are you, Golly?
Are you
there?
What's up? Right here.
Okay, great.
Yeah, I'm just like a hint on the
ventriloquism here, you know. It's like we just get the sound out of the speaker and you can't tell where the heck it's coming from.
Yeah, any hints, or is the Model 2 such a big deal because it decreases the cost of transportation that is really the disruption? Or should we get hyped that this new cost curve opens up different vehicle categories like a high passenger density bus, boring loop, boat, plane?
There are batteries in limited production right now that do exceed 400 watt-hours per kilogram, which I think is about the number you need for decent range, medium range aircraft. And I think our batteries will, over time, start to approach the 400 watt-hours per kilogram range as well. Yeah, I mean, I think over time we'll see all modes of transport, with the ironic exception of rockets, transition to sustainability, or to electric, basically. On the rocket front, what we're planning to do is like about 80% of Starship is liquid oxygen, and we're actually already running a power line to be able to use wind power to create the liquid oxygen. So we're making some decent progress on sustainability on the rocket front, but there's just no way to have an electric rocket, and it's important for the future of life and consciousness that we become a multi-planet species. So got to keep doing that.
I have a question in regards to the lithium and nickel industries and the likely price spikes and shortages of high-grade materials the EV industry is likely to see if they don't act fast to address future supply. Tesla have clearly made the right moves that are necessary, but there's a real worry that the potential supply issues and price spikes will create a drag on the rest of the EV industry and therefore a drag on global EV adoption. What advice would you give to the EV and mining industries to quickly solve this looming hurdles? Because for a sustainable energy future, the spice must flow. Thank you.
I'm not sure. I guess we can try to basically overdo it in cell production and perhaps supply cells to others. But we do see the fundamental constraint as total cell production. That's why we're putting so much effort into making cells and kind of trying to reinvent every aspect of cell production from mining the ore to a complete battery pack, because it's the fundamental constraint. We're not getting into the cell business because we, just for the hell of it. It's because it's the fundamental constraint. It's the thing that is the limiting factor for rapid growth. But we could certainly try to overdo it on cell production and perhaps sell cells to others. Although we are going at absolute top speed, so it's not like we're holding it back. But I think just making really efficient cars and that have low drag coefficient, low rolling resistance, efficient powertrains. I mean, that's kind of what we've done in order to make iron phosphate still have a good range. Because iron phosphate's lower energy density solution, but there's while there are some limitations on the total amount of nickel produced every year, there's really no limit on the iron. There's so much iron, it's ridiculous. So you can really scale up iron phosphate, at a raw materials basis faster, more than you can nickel. But yeah.
And just to point out, when we were walking through this presentation, we intentionally separated all the different aspects. The benefits of structural battery apply to a iron-based cathode in the same way they apply to a nickel-based cathode. Yeah. So you get longer range iron-based vehicles, and also the silicon benefit can apply to the iron-based vehicles as well. So we can do a lot to extend the range of an iron-based vehicle, which is why it's a key part of the roadmap going forward. And then I invited Turner up here to talk about what the mining industry can do.
Diversification on the cathode side is obviously massive, and EVs are all about efficiency. And so for the EV industry, for the vehicle industry, we need to see powertrain efficiency really increase at all other companies matching Tesla powertrain efficiency so that everyone can have that diversified cathode approach where LFP is used in medium range and even really make a 300-mile vehicle with LFP. And really the goal that we were trying to present here was a model for vertical integration, strategic vertical integration that a lot of different people can do. what we need to see is vertical integration that shortens the process path from mine to cathode. And what we're doing here is novel, and we're trying to push the industry in that direction. So we're presenting a model here that anyone can follow.
Yeah, in fact, if there's anything that you guys want to comment on, feel free to step forward and say something.
I think the key is to be smart about your chemistry choices,
Yeah,
your materials choices.
Talk louder.
Yeah, if you're smart about your materials choices, the spice will continue to flow.
Yeah.
You don't need to use the same kind everywhere. It's about strategically planning it out. And for miners, I think we are incentivizing them quite a bit to ramp up their production.
Yeah, and actually we had good calls. Like they're all motivated. I think that they've been sort of sitting back, being like, "Are you going to grow like crazy?" And we're like, "Yeah, we're going to grow like crazy." And then I think this indicates we're going to grow like crazy, and that's what the miners want to hear. And then they'll go make the investments.
Elon, this is Ben Limpick. I'm a musician. I was wondering, does Tesla have any future plans to make partnerships with music companies like it has done with 10-cent games or things like that for you guys to actually kind of expand your services for artists and other types of creative people to get involved in producing content that can be part of the Tesla ecosystem, or so other people that do creative things can get involved with you guys?
Well, we haven't really thought about that much, but I suppose it's probably something we should think about. We will be providing a title on Teslas. So we're providing more music sources that people can choose from, and generally trying to improve the entertainment experience in the cars. And I think actually, as we go to a more autonomous future, the importance of entertainment and productivity will become greater and greater. I mean, to the degree that if you're just basically sitting in your car, the car is fully autonomous and driving somewhere. It's sort of like being the car is essentially your chauffeur, and then the things that become important are, okay, well, let's have good entertainment, and if you want to do some productivity stuff, then that actually starts to become much more important because you're no longer spending your attention driving the car. So it will be extremely important in the future. The first one I think we already answered. Like if we're able to make enough cells, which we'll try to do, or we will supply other companies. It's definitely not an intentional effort to keep the cells to ourselves. If we can make enough for other companies, we will supply them. And we're trying to do the right thing for advancing the sustainable energy, whatever that is. Vehicle to grid, we get asked that a lot. I think one of the things that's important to note is the vehicle to grid. It doesn't, unless you have a power cutoff. Like you need to cut off your main supply to the grid. Otherwise, if you lose the power in your house, you'll basically just backflow energy to the grid. So just having a reversal in the power flow does not actually keep the lights on. You need a whole separate system to cut off power to the grid. And I think there's also the case that people really want the freedom to be able to drive and to charge at their house. And it's obviously really problematic if you get to morning and your car, instead of being charged, it discharged into the house, and then you're sort of, okay, now I can either drive or use the battery to power my house. I think it's actually going to be better for people's freedom of action to have a power wall and a car separate, and then it's everything works. And you add that, you basically combine that with solar, either solar retrofit or solar glass roof, and local battery storage. So you basically become your own utility, and then the car is can be charged also with solar. I think that's like the stuff that works. That said, like we can certainly do vehicle to grid. And I think we can basically enable that with software in Europe or something, right?
Yeah. We are future generations of power electronics. We will be able to do this more or less everywhere from a energy market participation perspective. But yeah, from a backing up the house, and it just so happens that the way the North American connectors are on all the cars in North America, it doesn't matter whether it's the Tesla connector or the connector that the other vehicles have, doesn't actually support powering your home. It's unfortunate. So you'd need an additional hardware to do that. But yeah, in the future, all versions of our vehicles will be able to at least do bidirectional power flow for the purposes of energy market participation. But even for that, it's important to remember that your car isn't plugged in 24/7. So it's kind of an unpredictable resource for the grid. It'll have a value, but it's not the same as a stationary battery pack.
Yeah, honestly, a vehicle to grid sounds good, but I think actually has a much lower utility than people think. I think very few people would actually use vehicle to grid, and we actually had with the original Roadster, we had vehicle to grid capabilities. Nobody used it.
How do we find the engineers to do everything we're saying?
How do we find the engineers to do all these things? I guess we recruit a lot of engineers from all parts of the world. You know, I think Tesla has a good reputation for doing exciting engineering, and that tends to attract a lot of the top engineers in the world, because they know that their efforts at Tesla will really serve the greater good, and we're super hardcore about engineering. You know, Tesla is like first and foremost an engineering company. It's like hardcore engineering is what we do. Like the sheer amount of hardcore engineering done at Tesla is insane. And if you look at, say, there's various surveys done of engineering schools, where do you want to go? Like, what's your top choices? And actually, the top two choices last few years have been Tesla and SpaceX. So sometimes it's Tesla first, sometimes SpaceX first, but those are the two top ones.
Yeah, I mean, if you are motivated to solve some of these problems, which are the hardest problems in the world to solve, that really fundamentally enable the future we all need, please reach out.
Yeah, and
help us work on these problems.
Absolutely, and like you said, the battle is far from over. You know, less than 1% of the global automotive fleet has been converted to electric, and even maybe less than 0.1% of stationary storage has been done. Stationary storage has barely begun. Converting the global vehicle fleet to electric has barely begun. So there's still a massive amount of engineering work to be done at Tesla and other companies to accelerate this transition to sustainability.
This is Jordan from Mark Asset Management. So you've talked about the importance of the factory, and you've mentioned the ground-up design process and a lot of the new things that you're going to be doing or started to do in Shanghai, Berlin, and Austin. Can you just maybe help us understand and quantify like how financially meaningful all of those improvements will be? And then given what you're trying to accomplish as a company, is it fair to assume that the vast majority of improvement will be given back to the customer in the form of lower prices?
I think certainly we will try to give back as much as possible to the customers. It's not like, it's not like Tesla's profitability is crazy high. Our average profitability for the last 4 quarters is like maybe 1%. So just to be clear, it's not like, we're minting money. Our valuation makes it seem like we are, but we're not. So we do want to try to make the price as competitive as we can without like losing money. And if you lose money, then if you keep losing money, you'll just die. So we have to. This thing called profit is just like we need to bring in more money than we spend, otherwise we're dead. So.
But affordability is key to how we scale,
Yeah.
right? Like the demand goes nonlinear as you reduce the price of the car.
Yeah, it's important to sort of separate the difference between affordability and value for money, or desirability of the product. So, for a lot of people, they want to buy a Tesla, they simply don't have enough money. We could make the car infinitely desirable, but if somebody does not have enough money, they can't buy it. Sometimes, people kind of forget this. It's like people have to have enough money to buy the car. And just making a car super desirable but expensive does not mean they can afford it. So it's absolutely critical that we make cars that people can actually afford.
When do you expect Tesla vehicles to beat ICE vehicles on initial purchase price? In the classes of vehicles we sell today, we're already doing that.
Yeah, we're already pretty close. And then factoring in total cost of ownership, and the fact that electric vehicles require much less servicing. And are way cheaper to run. When you look at like total cost of ownership, and you can obviously lease a car. So if you just like lease a car or get a loan for a car, you've got your sort of monthly payment, and then your cost for either gasoline or electricity, and your cost of servicing, and the fully considered cost of an electric car is much less than a gasoline car of the same nominal purchase price. I mean, that said, and like maybe on the order of 3 years, when we can do a lower cost car, like a $25,000 car, I think that will be basically on par, maybe slightly better than a comparable gasoline car. So I think maybe it's on the order of 3 years. ish.
Oh, I saw a cathode durability question. Let's go to that one. How are you going to address the cathode durability and cost and environmental impact trifecta? Is this something you're going to leave the upstream supply chain to solve? No, I think we tried to answer that directly. I mean, we really are looking at not just what happens in the cathode facility, but like currently outside the cathode facility that should really be inside, and removing processes that shouldn't have been there in the first place, and the use of reagents that are just costly and not necessary, and removing a bunch of wastewater from the process.
I just want to reiterate the fact that this is a massive problem.
Massive problem.
And it seems like Tesla's on its way and ahead, but we need everybody's help because it's everybody's planet, and we're not going to get to 20 terawatt-hours by ourselves. So please think about this carefully as it affects everybody. So let's get on it.
And obviously, if you care about solving sustainability and doing hardcore engineering, definitely come work at Tesla.
We went through a couple of the manufacturing improvements, and it kind of looks easy when you put together a nice slide deck, but the challenges are like this. It's super challenging when you take materials out of the process, when you integrate processes together. You have to do a lot of things at once, and that's like this immense engineering challenge.
The thing that sets us apart from a lot of other construction, we have a construction company here. The thing that sets us apart is that we're integrated in the manufacturing process. So every detail that comes from Drew's mouth is directly implicated into the system that we're building. That way, what would typically take 3 or 4 months to create a specification, our design team is working right with the manufacturing team to allow us to speed that process up tremendously. So,
yeah, it's definitely a important part of the vertically integrated approach is to be able to design the factory around the equipment, in fact, together with the equipment, so that you can build the factory at lower cost and more quickly.
It's hard to put into words how inspiring this is. I've been at it for a long time with Tesla, and
yeah,
I really hope others do join us.
Since when, Scott?
Since 2005. Yep,
yes,
with many of you. But thank you. But I'm really stoked at what the team's been able to accomplish over the last, short period of time, about a year. It's been really an incredible transformation. I mean, hopefully what we've shown you inspires you to join us or join somebody else in the effort. And I couldn't think of a greater, more intelligent, more hardworking team to be working on with this problem.
Manufacturing improvements is like the accelerator. So, like, you think about the execution that Rodney talked about in terms of how fast we've been able to put together this factory, which is amazing and something that's been really incredible to be a part of. That's not enough. What we need to do is improve the manufacturing technology. That's the real accelerator. And that's what we're really focused on. Elon talks about it all the time, that really going and improving that system is what will enable us to get to the scale and the cost that we need. And then the other point that I would make is on the recruiting side. It doesn't matter if you know about batteries. If you come from any industry, you can do something fantastic in the work that we're doing. We talk to people from industries that you wouldn't imagine. Like I talked to a guy who makes golf balls, and he has stuff which is really impactful for what we're doing. So, if you're in any industry and you want to be, impactful here, like come join us.
This is the most growth I've seen in a company. I've been here a little over a year and a half. We're hiring amazing people that are allowing us to leverage technology that most of the industry is struggling to achieve. So to answer the question, how are we going to do this? We are really advancing the materials manufacturing for cathodes and for lithium beyond what has been accomplished in the previous 20 years.
On the cathode and upstream materials side, it's really important that everyone understand that this growth is coming. This growth is real. We are going to make all of these batteries. Everyone needs to grow with us. The entire supply chain needs to grow with us. And if you have an idea that simplifies anything in the supply chain, come talk to us, come work with us, and let's do it.
Any existing specification is wrong. Any existing manufacturing method is wrong. Process equipment, it's wrong. It's just a question of how wrong.
Yes.
Quote
Exactly.
Elon Musk.
Yes, exactly. We're wrong. Just a question of how wrong. Just try to be less wrong.
So tell us how we're wrong and how we could do it better so that we can accelerate and improve as fast as possible.
All right. Well, I guess thank you everyone for coming. I hope you liked the presentation. Very exciting future ahead. We're going to work our damnedest to transition the world to sustainable energy as quickly as possible. and your support and help is key to that success. So thanks again, super appreciated, and look forward to the next event. Thank you.
Thank you.